Good afternoon everyone, my name is Matthew Keegan. I work for CamJam9, which is a DIY computer company based around the Raspberry Pi. I'm not going to be talking about that today. I'm going to be talking about something that's very, very dear to me, and that is edu-hacking, and it's a whole new way of thinking with education. I've had a tremendous privilege of being able to go to hundreds of schools throughout not just the UK, but Europe and further afield. In doing this, I've realised something quite profound. We live in a generation where kids are able to use technology before they're able to walk or talk. Where this is their way of communicating, it's their way of exploring the world around them. It seems like magic, but they're not exposed to what I think is the real magic, and that is the knowledge of how and why computers work and how and why the world around us works. And having been to all these schools, have we got any teachers in the room? Okay, quite a few. I think it's fair to say that teachers are terrified of this new computing curriculum in the UK by and large. I've been to many, many schools where they don't know how they're going to implement it. There are some fantastic schools out there who are already well on the way to delivering the computing curriculum. But to a lot of teachers, computing is a whole new realm because they've been very used to doing IT and digital literacy in the past 10, 15 years. And things are going to have to change radically to meet the demands of the future. For example, this is something I was playing around with earlier, and I spoke with someone, they were like, it just looks like mumbo jumbo. And I can see why that would be to people who weren't programmers. It can often feel as though you're being thrown in at the deep end. The last speaker mentioned that the computing curriculum in the UK is very small. It's actually 2 pages of description. And I actually had the ability to speak with the Department for Education about why this was, and their opinion on this was, well, we don't want to tell people how to teach. We just want to tell them the rough areas to cover and go from there. But the problem is this is a brand new topic. So it makes it very, very difficult to know where to start. So then the Raspberry Pi came along and interesting things started to happen. All of a sudden teachers had access to cheap computing, but more importantly, they had a device that their students could experiment with, they could make with, and most importantly, they could break. I remember when I was at school, the idea of messing around with a school computer was massively discouraged. In fact, a group of us found old letters from our schools telling us how we'd broken acceptable use policies for things that today we're actually encouraging children to do and to try out. So, for me, the big question is, what can we do? What can we do to facilitate bringing computing into schools? I'm very lucky in that I have a background in software engineering. At the same time, I also have some experience in teaching. So how do we bridge the gap between those two worlds? And for anyone that's a programmer, hello world, hello teacher, meet developer. This is kind of an idea that I have for where we could go with delivering computing, not just in the UK, but worldwide. In this building today, there are tens, if not hundreds, of people who are developers, IT specialists, programmers, engineers, and there's also teachers. And these two worlds, through the CamJam, are being brought together. So why can't we expand this outside of meetups like this? So one of the ideas is to pair schools with developers and bringing them together so that they have the mentorship that they need in order to deliver not just the computing curriculum, but to expand people's minds beyond just programming and to show them that computing is a whole exciting world of possibilities. Many people forget that actually things that I'm having a discussion today, things like maintaining server rooms, is a vital part of computing. Networking is a vital part of computing as well. Graphic design is another massive area. quality assurance. There's all different areas. It's not just all about programming. I'm sure for many people in the past 20 years, this is what an IT room would look like in a school. A lot of things are locked down. A lot of things are running proprietary closed software, such as Windows. And even Apple can be accused of this as well. It's an environment that discourages us from playing and making and experimenting. And actually, today, the CamJam, I would say, and hackerspaces are closer to this. It's bits and pieces of things being brought in, just big tables, and people with experience mentoring other people who want to learn, and bringing them together in an environment where they can explore and create. So the second part of this is to make schools more like hackerspaces than IT classrooms, giving people open source technology, open hardware, and the ability to learn more about technology through mentorship and through guidance of people who are in that industry. And there are hundreds, if not thousands of us out there who are all desperate to impart our knowledge and skills onto the next generation. And there's thousands of teachers who are trying to do the same. So my question to sort of the audience in general is to find out what your schools are doing and what you would like to do if you had the opportunity to change the way your classroom was today. And what do you think the important skills are that are either missing or are really valuable? So I know that we have teachers in the room. I don't know if anyone has experience of what they're doing. Yeah?
I would say the biggest thing, I'm probably slightly different because I'm at college and the university, so I've got them once you've done your job. But I find that problem skills and discovery, i.e. not being afraid of looking at what's actually happening and trying to understand it, and actually not understanding it is better because you know what it doesn't do, then you can learn what it does do. Those would be the things that I would want for people that are in school now. Don't be afraid to do what you're doing.
And that's a really interesting one, because we are in this age where getting the question right is what's important, and actually the learning process is kind of put to one side. It's yes or no, it's black or white. And actually, one of the things I love to say to people when I'm out teaching computing, I say, there is no right way of doing it. There's a better way, maybe. I would quite happily sit here and argue with you for hours about the best way to do something. But for me, I think it's more important that you did something to begin with, rather than sit there and ponder for hours whether this is the right way to do it or the wrong way to do it. If you blow out a board, you blow out a board, and that's the end of it. You get a new one, you move on. As you say, it's the mistakes you make that are often the most profound. How many people are doing the computing curriculum at the moment? Are there people who actually had any experience of it, and what sort of things are you learning?
Well, I've just finished it literally this Wednesday.
Congratulations.
Yeah, I think a lot of people found that. I mean, I'm going to play mainly because I think it may well be specific to my school. I'm not sure, but we were not taught a lot of the subject. We have a 3-year Key Stage 4. So 3 years to do our GCSE. First 2 were spent doing just binary, hexadecimal, and logic gates, which is understandable because those are very basic things. Logic gates didn't come up on the exam, but that's a different thing entirely. And a lot of people complained about that, but people still weren't getting it. Which, okay, a lot of our class we were literally lumped with people who didn't want to be there, who didn't have anywhere else to go, and they just needed to get them in a subject, in a room, where they couldn't. I mean, we were sort of just, the reserved subject for whoever they couldn't find elsewhere for. So there was a definite segregation of the classroom, and literally physical. There was those who kind of knew what they were doing, those who didn't know they were doing what's on one side, people who were, I'm going to use the word hopeless, but who half of them left. And what's worrying is that it was we had. the most amount of women we had in the class were 3. 2 of them left. We had one go into the classroom, and I'm afraid to say she wasn't one of the people we would have expected to do great, and that is such a shame that had to happen. But going to the exam, I felt confident, but that's only because I spent 3 hours the night before revising, memorising the entire booklet that we've been given. Most people weren't given that. Our teacher, bless him, he did try his best, and I think he tried a lot harder than a lot of computing teachers would have done. But he was about a step behind us a lot of the time. He was still learning, so a lot of the time he did attend courses, and I'm really grateful that he did, because at least he was trying. At least there was a sign there that he was doing something. But a lot of people came out of that exam very disheartened and were very much sort of, this is a shame.
I think that brings up 2 really important things. First of all, how many people have been involved in a code club or a coder dojo or things like that as well? That's wonderful to see. Actually, you were saying that one of the big things is actually this idea of those that want to be there and those that aren't interested. And that often comes out in the education system, where people are forced to take a subject or don't have another option. So actually code clubs, people who go to those, that are one of the best places to start with this. And actually I encourage any teacher or a person in education to go and try out one of these clubs. They're absolutely fantastic. Was at Coder Dojo last week. In fact, ran 3 of them. Kids want to be there. They want to learn. They really do want to learn this stuff. And I think the second point is exactly what you said. It's the idea of, in the education system, we have this policy of teaching very, very categorized parts of the topic. You will learn hexadecimal. That's a module, that's on there, that's what you need to know in order to pass this exam. How many times have I used that since I left university? None. How many of us are in jobs that we trained for when we were at school or university? I certainly know I'm not in the job that I thought I was going to be in. I trained as a software engineer, and I'm not a software engineer. I'm pretty bad. I love tinkering, I love talking, and I've combined those skills, and I'm in a job that needs those skills. But what are the skills of the future going to be? I know that people are going to, actually, we were talking earlier about Apple products. Who could have imagined that we'd have watches that would be on our wrists that would be able to, talk to our phones and tell us, all the boring meetings we need to go to today. We couldn't have imagined that 20 years ago, yet there are people today who are designing those items and who are working in that industry. And the other thing that I want to talk about is the tools that we provide. And this is why it's important to speak with developers and people who are in industry and pair them up. Many of us are using tools and know of tools and resources and websites and people to speak to get advice and help. But unless you are in that field or you have an interest, it can be very hard to find it. A great example, I was talking to someone earlier who makes fantastic Raspberry Pi YouTube videos. Unless you knew what you were looking for, it would be very difficult to find that information unless you were actually actively going and saying, I want to know about how to connect a motor up to a Raspberry Pi this way. Definitely it'll come up. If you're a teacher and you want to learn for the first time, what's good? Is this project good for a year 4? Is this project good for a year 6? Does this meet the needs of this curriculum? How can I teach this in my classroom? It's very, very difficult. And this is where the idea of bringing developers into the mix is. And one of the proposals I would make is that we need to have a group of people who are coming together and collaborating to bring these resources into one place. There are some teachers in London who are doing amazing things with offline computing, where they will give each child a number, line them up, mix them up, and then they'll try and get them to sort themselves out. And they have to write a sequence of steps. And without realising it, some of the children came up with bubble sort. And amazingly, one of them came up with quicksort, which is very impressive for a 9-year-old. Yet they'd never actually sat down and looked at it. Another one that I've done with classes, which is quite a famous one, is to use your arms as a robot and to show children that actually computers can't understand natural language very well, and that we have to give them very precise instructions. And using these examples is fantastic, and it could be working really well in a school in Putney, yet a school in Lincolnshire will never ever hear about them, because we're not connected, because we're not sharing. And that's a shame in this digital age, because we're more connected than ever, yet actually we're more separated than ever. So my final proposal would be that actually we all come together, we work as a team to share knowledge, to exchange resources, and to come up with a standard for the way in which we share our information. For example, I regularly write projects for the Raspberry Pi, yet they're stored in my company's database because that's the place we put them. It's probably not the best place, but it's what we have today. And one of the proposals I want to make is that we come up with a standard so that anyone can access the sum of human knowledge in computing in the same way that Wikipedia has done it for the sum of human knowledge in general. We can do it, we can achieve this, but we need to work together. And I would love it if anyone would want to get involved in this, to facilitate bringing people together, be it schools here in the UK or abroad, bringing developers together as well, and trying to pair schools and developers up so that teachers feel as though they can have a mentor and an advisor on the technical side of the curriculum, and the teachers can do what they do best, deliver fantastic lessons and wonderful pedagogical principles to their classrooms. I think we can do it. I think we can improve education, not just in computing, but as a whole, by bringing people from industry and people from education together. Thanks.